I'm Yvonne Schwab. Well, I'm Yvonne Schwab, the CEO of ACG Silicon Valley. We are very excited to welcome you tonight to our event on the future of transportation. First off, a big appreciation clap to our host, Morrison Forster, for having us here tonight at their beautiful office. Thank you so much for hosting us. We're truly grateful. And if you are new to ACGSV, we're the leading business-to-business networking group in Silicon Valley, comprised mainly of CEOs and top-level executives. Our executive community enjoys unique offerings like our monthly panel discussions, such as this, spanning a variety of engaging and thought-provoking topics. Moreover, our 8 industry and vertical focused circles provide ample chances of networking, showcasing expertise, and advancing professionally. We are one of 61 chapters across the world with over 15,000 members, offering local connections with a global reach. Now, just a quick mentioning of our upcoming events. On May 1st, we have our C-Circle taking on the topic of venture capital and private equity outlook for 2024 and beyond at JP Morgan Chase in Palo Alto. May 14th, our CTO and Innovation Circle is hosting an event titled Empowerment Circuits, Women Shaping the Future Through AI Mentorship and Networking in Palo Alto. And on May 16, our M&A Circle will be exploring AI investments and exits, the New Deal Frontier at Reed Smith in Palo Alto. Of course, one of our biggest events is coming up in a mere 2 weeks. Don't forget to get your tickets to our Exceptional Grow Awards on May 9th. Definitely not to be missed. And last but not least, I wanted to tell you about our inaugural ACG Silicon Valley M&A Tech Connect conference scheduled for October 1st and 2nd of this year at Levi Stadium, the 49ers home. More information coming on that coming very soon, so stay tuned. And for all of our upcoming events, please visit us at acgsv.org and register early. Now, it is my pleasure to introduce you to Chris McKinnon, partner here at Mofo, who will be our moderator tonight. So big applause. Thank you so much. Thanks, Chris.
Thanks, Yvonne. Thanks, everyone, for joining. As mentioned, I'm Chris. I'm a partner here at Morrison & Forster in Palo Alto in this office. Been here for close to a decade. I focus principally my practice on emerging companies and venture capital and M&A to the extent it relates to venture-backed startups. In the last 12 months, we've done a lot of interesting deals, including that touch on things in the future of transportation space, including drones, solar-powered startups, other things relating to factors like that. I'll turn it over to each of the panelists to give a brief summary of their backgrounds and experiences in the space, and then we'll get started.
Hi, everybody. Good evening. I'm Cynthia Bainan. I'm a partner at RSM and our national leader for our regulatory compliance and financial crimes practice. I have 24 years of experience serving clients with navigating the complexities of regulatory matters across a number of industries. I have spent some time supporting the aviation industry as well, mostly in the vein of responding to Fed matters. So I've seen a number of things and really excited to be here today to talk about the regulatory requirements in this very exciting innovation.
I'm Jim Duchovny, CEO of Olive. We're doing flying cars. I don't know what to add. Last year, we pre-sold close to 3,000 cars, which makes it more than Boeing, Airbus, and most of the eVTOL industry combined. We have the social network and the news reach of over 2 billion people. We're still in early stages, though, so we're still fundraising. But yeah, the number one question is, yes, the car drives, flies for the last 3 years, so it's here, but no, you cannot, well, you can place a pre-order, but we cannot deliver it to you yet.
My name is Mario. I have been working for SAP for 15 years as a software developer and manager and then innovation strategist. And for the last 10 years, I've been doing it on my own, writing books about technology trends from the Silicon Valley. And one of the books that I wrote in 2017 was about the last driver's license holder has already been born, writing about EVs and autonomous vehicles, which were being developed here. And then was the question for me, okay, what's coming after that, after 2035? And I looked at flying cars, maybe, ha, ha, ha. Well, and I said, okay, I don't know anything about it. And 600 companies trying to develop that. But you will hear more about that today, more expertise than you can hear from me. Thank you.
Great, thanks all. I think to start, before we get to the future, we can discuss a little bit about the present. What are some of the common problems that each of the panelists, what do you see are issues and problems with today's transportation systems that can be improved upon with future iterations of better modes of travel?
I know a lot of problems, but this is actually, there's only one problem, the main problem. Most of the problem with today's transportation is very simple. It's called width of the road. The reason you're stuck in traffic, the reason it's not efficient, the reason you lose so much time in traffic, the reason the economy uses trillions of dollars, loses every year, is simply because the width of the road. We used to have horses. The only reason we have cars today is because cars were supposed to be faster than horses. That's not true anymore at 5 p.m. in San Francisco. The horses probably will be faster than cars. So car itself as the mode of transportation is getting pretty outdated. And again, for the simple reason is the width of the road. In cities, every 20 years, you double the amount of cars. So imagine San Francisco today at 5 p.m., twice as many cars. And there's no more room to make the roads wider anymore. So imagine 101, 5 p.m., twice as many cars, right? That's the issue. The current transportation is not handling it. The second part is interesting that in US, the adoption of EVs is actually not that good, right? So the electric transportation, which looks good in theory, but the adoption is not good. Why? The value proposition is not there. A lot of people facing choice between Toyota and Tesla will pick Toyota. Most people in US will at this point. How do we make it work? How do we make it work? And again, the way to make it work is probably to make the, again, the value proposition is better. But basically, this is biggest problems. The current modes of transportation are not efficient. You always have bicycle, you always have a bus, a metro, or anything like that. But most of your transportation is a commute. You go from work and back to work. Most of you use car for that. And that is an issue. Car is not that good because of the width of the road.
I agree. I think that's a really great concept. I also think about it from a cultural perspective, right? And comfort, and what do people feel comfortable commuting to working, taking care of their day-to-day responsibilities for work and life. So I live north of here in Seattle, and Seattle's been trying to get the public transportation off of the ground for, I would say, 30 plus years. They are just introducing a light rail. It really doesn't have anyone on it. So when we look around, we think people feel really comfortable in their car. It's their space. So how do we adapt the car, similar to what Jim is doing at a left, to be a comfortable space, but also help support our limitations in the infrastructure. And that definitely will be a cultural shift that we'll see, and people have to get comfortable with it across the board, really, right? There's trust as well in this new mode of transportation. Exactly as Jim was also mentioning with the electric car and, the traditional gas-powered car today, more people will stick with what they know versus the unknown. So how do we build that trust in that space. And that'll be really critical to making all of this kind of come together.
Well, I look at it from multiple perspectives. One is mobility is social life. Yeah, we are connecting with it. We've seen it in the pandemic when we couldn't travel or go somewhere and couldn't stay in touch with people or stay in touch with products or stay in touch with places. Yeah, traveling to vacation places. And there are multiple forms of that, of course. In the US, we see that 95% of the cars are always parking. So it's a huge waste of resources. These cars are expensive. Yeah, we are designing cities to have cars parked. A lot of money is spent on that. The way we design cities, houses, increases the cost. We have 28 parking spaces per car in the US. We have more cars than people with driver's licenses in the US. So these are all the things that we have to calculate. That's one problem. Even if you have in Europe more public transport, to look at that, they're also missing things like the last mile. Some people may not have access to public transport, especially in rural areas. People may not feel comfortable going on public transport, like women at night, or handicapped people, or people with other reasons not to use that. And the third one is that even if you have public transport or logistics companies, yeah, we have a bunch of logistics companies today here that I brought with me from Germany. It means with the increase in demand for public transport or logistics, they can't find drivers. There's a gap. We heard numbers in the US, they're similar to Europe, 80,000 drivers are missing. California has 3 times as many drivers that are really active as truck drivers. And there's a shortage and nobody wants to do trucking. Long haul trucking is difficult. So these are all the challenges that we have with transportation. And so we need to find better ways to do that.
Yeah, and hopefully with a combination of autonomous and electric vehicles, we can both reduce congestion, traffic, commute times, accidents, all things of that sort. I think we can move now to the future. And in that respect, Jim, could you tell us a bit more about what you're building, how you intend to kind of make money with the business and put people in the air in flying cars?
Well, coming back to the previous one, so we talked about the problem. So what is the solution? The main problem is, again, the width of the road, to which point the self-driving cars, the connected cars may not solve anything, because doubling the amount of cars, you still have the same road. It will be more efficient, but you're still not going to see the problem. You're going to put more throughput through the same width, right? So what do? You remove the constraint. The only way to do it is remove the constraint. By the way, same argument about Hyperloop or anything like that. As long as you have a constraint, as long as you try to put more and more throughput through the same exact amount of width, good luck. I mean, there's the laws of physics. You cannot go around the laws of physics. So first, remove the constraint, right? You still have probably some ordered lanes, or if you want to call it, they're not actually lanes in the air, but basically here's what you have. First of all, you can expand and contract this way, but moreover, you also have the y direction. Y direction also helps because you never have a stoplight, you never have like anything stop, right? Because they're crossing it in the y direction. Moreover, you can scale maybe like 1,000 to 1,000,000 times of cars which we have today on the ground. So all of that provides you that scalability, that efficiency. And technically for the next 100 to 200 years, we should not have any traffic at all for the same reason, because the amount of space, because of the laws of physics. It's simple geometry and simple laws of physics in there. How we get there, it's completely different story, because the key to getting there would be safety, right? That's a main reservation probably most people have with the flying cars. When they have flying cars, it's like a safety. How are you going to put a kid in a flying car, right? You do put a kid in an airplane, you do put a kid in a car, which means that flying car should be safer than a car on the ground and safer than an airplane in the air. And they actually are, but it's a longer conversation. If you need to, I'll go to the next question.
Great. And your company specifically, do you have a timeline or when you think that these good people might be able to get in a flying car themselves?
So we've been flying for years. I mean, the prototype itself, there's a physical car which you can drive, you can take over and you can fly in this. There's enough information available online if you just Google Aleph flying car. There are videos, there's pictures, there's enough information there. As far as delivering the first commercial product to somebody, I know that's a favorite question media ask me, like my answer goes usually like this, and for some reason, media just prints the last word. If everything goes right, if we have enough resources, we plan to start the production of the first one by the end of 2025. Media always prints 2025. Jim said 2025, you're going to have millions of flying cars. No, that's usually how it goes. But the technology we already have. It's here.
Very cool. Mario, would you mind also telling us what you see for the future of transportation, new technologies and advances, other than or in addition to flying cars?
So thanks to the technology that we are seeing are coming, like electric vehicles that allow a complete different forms of mobility and transportation that we have, including now with another technology, AI, at least from this perspective of self-driving cars, that you could have something like, why do you go to the supermarket when the supermarket can come to you? Yeah, like a Robomart, a company doing that, where the vegetable store comes to you, or the shoe store comes to you. Dangerous for my wife because she loves shoes. So we would have probably a line of shoe stores parking in front of the house, which I try to avoid. But then we see also something else. You may have heard about things like the Tesla bot, Optimus. Now, Musk or Tesla or other companies that build such things consider them as things that are helping you doing something either in the factory or at home. But these are also things that can walk in buildings and walk to the next restaurant and bring you your food. Yeah? So this is a new form of mobility that we have here on 2 legs or 4 legs or whatever it is, and bring you that stuff, and is more energy efficient than a 2-ton vehicle with a driver that brings you your DoorDash or Uber Eats food. And they can move in buildings. That also means, and it brings us to the question, do we need to consider constructing homes in the future that are robot accessible? Yeah, so like we have handicap accessible, we spend a lot of money to do that in order to get that, and we all benefit from that. Do we need to do something for robots that they can press a button on the traffic lights or open a door with different types of handles, yeah, and move inside the buildings? So this is where I see the future of mobility heading. And with generative AI, you see now a combination of that, where this thing can talk to you naturally. This thing can identify millions of objects because it's pre-trained through a GPT. And suddenly I think we will see here an explosion, a Cambrian explosion of robots that are really intelligent and that are also mobile and help us transport stuff.
That's great. That's very exciting. And I hope for that in the very near term. Hopefully we can get all of those great innovations tomorrow. But Cynthia, might you be able to shed some light on maybe some of the regulatory issues present in that?
Yeah, absolutely. And I was thinking, listening to all of this, right, and particularly the flying car, obviously the FAA is the prudential regulator or regulatory agency in the US that sets those requirements. And when we look, since the founding of that organization in 1926, which actually was founded after the first airplane and even after the first military airplane was around, but thankfully before the first commercial airplane took off in 1933, carrying 10 passengers. Historically, I think a lot of people have thought of the FAA as a stale body. I'm sure you have your stories and interacting with them, but in July of 2023, they did release the Advanced Air Mobility Implementation Plan, which does specifically cover the vehicles that can, vertically take off, as they call them, eVTOLs. And it was interesting taking a look at it. One, it signals, obviously, that the FAA is on board with this transformation. And they are trying to keep themselves relevant as the world is changing and people have access to new technologies. And their primary focus, obviously, is making sure that those modes of transportation are following the rules, they're safe, they're sound, consumers can trust those vehicles. And so I think we are seeing a little bit of a softening, at least through this implementation plan, that they're open to the idea of it. There's still a lot to learn, right? And you can probably share your experience as well as far as restrictions on where these vehicles are allowed to take off, you know, what type of barriers are underneath those vehicles, the distance in which they need to hover above city buildings, flight plans, and things along those lines. A couple of interesting points through that document is that the FAA is definitely taking the position that the current air traffic control system that they manage may need some modifications, but they really are looking to state and local agencies to figure out what the mechanics might be from a air traffic sort of control mechanism, knowing that these vehicles could potentially be flying around in the next 5 to 10 years or whenever it gets off of the assembly line.
Yeah, that's very exciting. Hopefully it gets some innovation going in the regulatory department as well. So Jim and Cynthia, to you both, or either of you, do you see significant differences between kind of California and the United States as a whole versus other jurisdictions, other countries? Are some more laxed, more restrictive? And do you see that changing over time in the near term?
Do you want to go first?
So yes, California and the United States. So far, California is in the United States. So no, because FAA is a federal aviation authority. So the sentence which they told me, and this is literally a sentence from them, I can quote them: if you jump, you're under control of FAA. Anything which is above the ground, that's under the control of FAA. That being said, outside, yes, there's a huge difference between the United States and some other countries. This is what we're trying to exploit, actually. In some other countries, we're legally allowed to fly today with no certification whatsoever. One of these countries, like Canada, UK, Italy, and there's like several other countries too, actually quite a bit of them. Another good thing, which is a good thing, and it will be good for consumer and for us, there is something like a war between the United States and China happening, as far as the regulation happening, because China has already approved several what is called eVTOLs, electrical vertical takeoff and landing aircraft. United States have approved 0, but they're starting to put more and more and more. Congress passed several, and not laws, but like they passed several things. I'm not sure what they called. They're basically creating departments, so they are working on it. And the primarily driver is driving because that is the China success. There's also Europe is a big player, Scandinavia, other countries. So that competition, the free market is actually good. And the competition between government is also good. It's good for everybody, for the governments, for the consumers, for us, for everybody. So it's a good that they have competition. I agree with you with what you said, is that FAA is trying to do 2 things. On one hand, it is reacting to eVTOLs, and by the way, we're not eVTOL, I can explain why, but like it's reacting to eVTOLs on those vertical takeoff and landing electric aircrafts. So it's passing, it's trying to stay up to date, definitely talking to everybody very aggressively. On the other hand, it's extremely conservative, and it treats us as an airplane. It looks at us as we are Cessna, as we are Boeing, as we are Airbus. We're completely different beast. And sometimes it kind of doesn't work, and I feel like we're speaking different languages, but I really appreciate them trying.
That usually is, and that's why when Chris and I were connecting before this event, I was like, everyone here really wants to hear from, Jim and this exciting technology, the regulations are really in place to keep people safe and have those rules so that you don't have a bunch of people flying around crashing into each other, 500 feet in the air, right? So there has to be some control and some traffic pattern up there, right? Hopefully, as Jim was saying, right, in that vision, and we are visual people, here we have parameters of a 4-lane or 6-lane highway. Up there, it is, much larger. I think in, California specific, there's a lot of really smart, forward-thinking individual engineers concentrated in this particular area. And I think obviously Jim is one of them. And there's a lot of like-minded people that are trying to disrupt what's happening today, thinking about where we should be going, how can we utilize transportation in different ways that are safe, quicker, easier to access for all people. And I think that's really where that direction is going. And, I'm glad to hear that Aleph is here. And, I think it creates a lot of opportunities for people in this area from a job creation perspective as well.
That's great. And now for a moment, let's envision the FAA and all regulators say, all flying cars, all drones, perfectly legal, go for it. Other than regulatory concerns, we might have an issue with customer adoption. In the customer adoption space with respect to EVs, for example, 2 key factors people mention oftentimes are range anxiety. They don't want to get stranded before they reach the next charging station, or the cost of EVs, maybe many more things holding people back. But when it comes to getting in a flying car, maybe aside from purchasing one, what are some of the key constraints you might foresee customers in stepping into those?
So there's like a cool story, like some time ago, I got like there's a bunch of those cool stories, but like I got a letter from I think Nebraska school teacher, like early school teacher, that kids were writing letters to Mr. Duchovny. It was questions about flying cars. And one of those questions were, what happened if I run out of gas out in the air? That's kind of the question which you were asking, right? Yeah. So first of all, you always run out of gas because we're 100% electric. That's number one. Number two is, so think about similar to happens to your drone, and we're not a drone by any means, but if it sees that it's like you're 20% or less or anything like that, it will automatically land you. So you will always have some kind of a buffer. That's number one. There are many, the one thing I mentioned earlier, and now I can dive a little bit deeper into that. The adoption, the only way the adoption should happen is something as early as the flying cars, and especially it's again very similar as people were going from horses to cars. It's safety, right? This is the number one concern by far from everybody. Like, how do I put my kid in this? So it needs to be safer than an aircraft. I can give you several examples how this is safer than today's aircraft. Number one, it has much more redundancy. If you fly today in your Boeing, Airbus, wherever you're going, you have 2 engines. You heard a lot of times, like 1 engine failure, it's fine. 2 engines failure, you maybe like glide or anything like that. We have at least 8, which means it's at least 4 times more redundancy. Moreover, there's a redundancy between systems. The whole system goes out there. And by the way, they're completely independent systems. It's a motor speed controller, propeller, battery systems, right? So even if 1 battery fails, or even if 1 propeller fails or anything, you can have 4 fail, you have 5 fail. You're still kind of okay, right? So there are redundancy in the systems, the redundancy between the systems. We can literally stop in the air. There's an auto land, you can go back. We're also extremely light. There's some term called ultralight. Ultralight is a different kind of aircraft with a special category, which means we can have ballistic parachutes, very kind of a small parachutes, which can very slowly and very safely land your aircraft. But if you're going to calculate the probability of anything happen with a lot of new safety features which were added, which were not happening right now in any helicopter or aircraft, the new features which were added, if you're going to calculate probability, we're maybe 100 times safer than anything which is flying today. So by the time you will get to probably the ballistic parachute, it's very unlikely you will get there. And if you will, it will land you very, very, very slowly. So if you compare to today's aircraft, it's much, much more safer for many reasons. I just mentioned a few. And all those safety features which we have are in addition to the safety features which you already have in an aircraft where you take your kids and you're doing everything like that. So safety is the adoption. It's the number one thing. The way to consumers, I mean, we already have 3,000, we already pre-sell more than any aircraft in history. So there is a hunger, we know that, but those people are early adopters. At some point it will level, and that would be the key kind of a metric when it's going to level from early adopters to regular adopters, and then it's going to scale.
Great. And Mario, any comments from you on the flying car when it comes to either regulations or customer adoption?
Maybe not so much to the flying car, but something I think that we can take as an example then for the flying car of how other companies like EV companies or AV companies are approaching that, because they have the same issues. Like, what is if I run out of electricity of charge in my car? Yeah. What if the car makes a mistake, like in the AV? Yeah? What is if the grandma is here and the baby is there and the car cannot brake anymore? Whom should it kill? Yeah, that's the wrong question, because we are not deciding here whom to kill, but we are trying to build something that doesn't kill anyone. Yeah. So. The way beside that, the technology is of course one where we try to develop that. Jim is doing that to be as safe as possible. There are these two other obstacles. One is the adoption. We mentioned that already. So how do you solve that? Let them experience it. Who of you has ridden has been riding in a Waymo with already experience? Yeah. The majority, of course, all my people over there should raise their hand, because every one of you. So once they're in there, after like 30 seconds, when the heart was pumping, did I do the right decision? Yeah, should I have written my last will? Did I turn off the gas stove? After 30 seconds, it's over, and they said, "Well, it feels pretty smooth. Better than my wife, or better than my husband, yeah, or better than the Uber driver from the airport, yeah." So and then I see then how they get comfortable with that, because we talk about something else than the car that we are in, the robo car, yeah. The same with electric vehicles. Once you sit in there and experience it, then a lot of questions are already answered. Then once you're there, so this is happening. So you have to give them the experience of flying in there. And then the second, and then the other point was, we've seen that with Waymo. Waymo, the AV company, robotaxis, you've heard about them by Google. They just recently got the license to drive also all the way from San Francisco down to Sunnyvale and cover the entire Bay Area commercially with driverless cars on highways. And the reason why they got it so fast, within a few days they got this license, when they applied for that, was that they had a lot of interest groups vying for them. Basically, Mothers Against Drunk Driving, or the Blind People's Association, or Black business people. So in order to get support, it's not just that flying car company CEOs have to talk about how great the technology is. You have to have other people talk about that. Like people that are today do not have access to individual mobility due to certain reasons. And that is something where you have to work with the community. Otherwise, if you're not doing that, then it happens like Cruise, where they're bashing Cruise and then taking them off immediately as soon as they do something wrong.
That's great. Well, I certainly have some more questions. I see we have about 15 more minutes. I certainly want to open it up to the room. If there's any questions for any of our panelists, please do let us know. We have a mic, or you can just shout out any questions. Let us know. Please.
How do we price of the car down so the price of the flying car gets down to a reasonable level where it can be more accessible to middle America? I think about how
dense the population is in South San Francisco, how do we, and there's power lines and, lights and street lights. Will the car be able to navigate the immediate obstacles that are like trees and just to take off and land? Is that something that gets handled fairly easily?
Right. This is where the regulations comes in, right? Like you're not going to be able to take off anywhere. You're not going to be able to take off next to the White House, no, where there are like the power lines above you. There are like a million places where you should not be able to take off. But there's also a million places where it's absolutely safe to take off, right? So what I think, and for the lack of the better terms, initially it's going to be only like a whitelisted areas, only certain areas where you're allowed to take off, which is going to be extremely restricted. And later we're going to come to the blacklisted areas, the areas where you're not allowed to take off, but everywhere else you are. That concept which I'm talking to you, it's not that I came up with it. We talked to City of Mountain View, City of Palo Alto, we talked to local cities. That's who come up with that concept. So it's pretty obvious that this is kind of how it's going to work.
And if we think about this, there are a couple of barriers to entry too in this new model. Right now, the current designation of these vehicles are called low-speed vehicles, meaning ground speed has to be somewhere around 25 miles per hour. So if you think about how we utilize our vehicles today, we might be driving down the 405 at 70, if there's no traffic, or we could be stopped going about 2 miles per hour. So I think, that concept as well will be hard for people to get their arms around until regulations change for the designation of vehicle, allowing it to be more road speed. To your point, there's definitely height restrictions as well. They have to be able to fly over a certain number of feet that's agreed, not only by the FAA, but by the municipalities or wherever you jurisdiction you're in utilizing the vehicle. The other thing that's pretty interesting, and I don't know if this will change over time or not, but today you have to have 2 driver's licenses, your regular road driver's license and a air license, like a light pilot license as well. So that means 2 tests. So I think over time, as this becomes more of a reality, the FAA is going to have to change their rules so that it's easier for people to access this mode of transportation if their goal is to actually innovate.
Right, to the point of that, so people a lot of time, like especially interviewers ask me questions from the media, everybody thinks tomorrow there's going to be millions of cars above South San Francisco or above Palo Alto. That's not going to happen. It's a very slow incremental process. And during the slow incremental process, regulatory bodies react, right? This is usually how it goes. I can't remember when FAA actually did something before something happened. So they usually react, right? And this is why I'm a huge fan, and this is what we do from the business standpoint, incremental approach, right? It's going to be 1, 2, then 10, then 100, and so on. As we're going to go along together with the regulatory bodies, we're going to adjust. So for example, to your questions about what if there is some malicious person who wants to take off in some bad place? It's pretty simple restrict from the technology point of view. Then you can hack it, and then you start having this game. But anyway, this is where technology and the regulations should be working together. To that point, though, I think they should be working together much faster and much more friendlier. But yes.
Is related to, here we go. Okay, my question is related to the experience itself, and also have a lot of experience with air charter and FAA regulations. So trying to visualize what the future looks like. So would you be considered like a pilotless vehicle where you wouldn't have to, you wouldn't have the pilot, but you would, whatever the scenario is, right? You put in the address where you want to go, and it's kind of like Whisk is putting together their pilotless, airplane, or do you foresee, I know you mentioned a light pilot's license. I could see that being a big barrier to entry. It's very expensive. You don't just take a test, like you have to go through training and stuff like that. So I guess twofold is what's that experience, and maybe would your market be more towards pilot? I mean, there's lots of pilots, but you know, kind of how are you getting started with that?
This is a really great example of what we were talking about. This is a perfect example. So from the actual safety point of view, you're so much safer flying pilotless, autonomous, where the actual vehicle makes the best decisions for you. It actually communicates via API with the tower and everything like that. Those things already exist, by the way. They're still being rolled out. It's much safer. But there is no way anywhere in the world, anywhere on anybody's roadmap to fly autonomously with a human inside. This is completely impossible. This is where two things come together.
So basically, initially, it's like you have 3,000 orders. Is it pilots that are buying these?
Not necessarily. So remember, I said not United States. So we plan to do in other countries. In other countries, you do not. In some countries, you do not have some pilot license. In some countries, you should have like a ultralight pilot license, which is not even comparable to the regular pilot license. So it's a different.
Okay, thanks.
So do you visualize that these will be parked like at an airport, and you will have to go drive to the airport, somehow get to the airport to find your vehicle that's going to fly? Or are these going to live in garages the way our cars do?
Very good question. And that brings up the answer to the other questions. What's the difference between us and eVTOLs, right? So eVTOL, if you have an eVTOL with electrical vertical takeoff and landing, think about it as electric helicopter. The answer to your question would be yes. If you have the Aleph flying car, and again, you're welcome to Google Aleph flying car and how it look like on it. It actually, the physical car, it looks like Tesla, it drives like Tesla and everything like that. So you would have it in your garage. You would use it exactly as Tesla, and we're talking about the takes off. To answer your question more, yes, we did that. We actually took off from the parking space and we actually landed on the parking space. And yes, we keep it in the garage today.
Hi, Jim. When I saw you were speaking today, I just kept sort of coming up with ideas on the way driving down here, which took a lot longer than I anticipated because the road got really narrow. And as I tried to get off Oregon Expressway, which is the most misnamed road in Silicon Valley. But I was thinking about, I could see the future. Have you thought about rideshare like Uber and Lyft, where you look at the interface and you think, am I going to get Uber XL, Uber X, Uber, whatever new category that they've come up with, and then you think, well, I'll get an Uber Aleph, and that's marginally more expensive, I might add, but when you look at what the journey time is, it gets halved or even a lot less than that.
That's a good question. So let me tell you a story. Some years ago, I messaged Travis Kalanick, founder of Uber, and he actually answered. The reason he answered, it's cold email, completely cold email, and Travis answered. So the reason he answered is he's actually a very forward-thinking person. And many years ago, before everybody, he was working on Uber Elevate, what's called Uber Elevate. Uber Elevate, by the time, Travis actually left, some other people took over, had what you're saying. They already had it. They had the eVTOL, again, we're not an eVTOL, but like something like that, already listed. Here's Uber X, here's other Uber, here's eVTOL. Here's the flying, here's the times it's going to take you with an Uber X, here's the time it takes you, here's the time it's going to take you with the, they call it flying taxi, eVTOLs, right? They already had it. The problem was, Travis was not CEO anymore. They actually sold it to Joby. Joby is one of the eVTOL companies. So now Joby owns the Uber Elevate. But what you're talking about, it's actually already exists and already existed. Now, when you're talking about the price being up, that should not be the case in our case. It actually should be lower, because I can explain why. It's probably a longer explanation than here, but I'll try to condense it in a couple sentences. We're actually greener than Tesla. We're actually greener than any eVTOL. We're actually greener than any electric vehicle. The reason for it is we use less energy per trip. The reason we use less energy per trip is because the amount of miles, the road is more straight than 101 or like in Oregon or anything like that. So we use less amount of miles, hence we spend less amount of energy. Hence your trip actually, when we can get the price of the car down, and the way to do it is actually to produce many cars, it actually should be lower than UberX.
Hear me? Oh.
There you go.
Okay,
You're
okay,
good.
there you go. Okay. So what's the maximum velocity the flying cars can have right now?
Well, maximum is maybe not the right question, because you're not going to do the speed flying in this. You may. I mean, there's actually really people doing the league of speed flying, but it's probably not what we do.
Is there a legal limit actually today set? Because you already have orders. So,
I don't know if there's a legal limit in the sky of how fast you can fly.
okay,
We're not even close to the limit of
okay,
even on the ground.
okay. So, but I mean, have you tested your flying cars to see what is the limit and what's a safe limit? And have you done those tests?
Right. So what we tested is, it's called a cruise speed, right? You're talking about maximum speed. Cruise speed is
Right.
something else. Cruise speed is where you're flying at the most optimal level. So when you're flying at a cruise speed, you're using your, in this case, battery, right? The energy, the most optimally. If you fly slower, it's not going to be good. If you fly faster, it's not going to be good. This car is not meant, again, for racing or anything like that. Our cruise speed is actually 110 miles per hour.
110, okay.
That's a cruise speed.
Okay, get it. And that probably is the practical.
It's not the limit.
No, it's not the limit, but that's a practical number, because that's
It's a
probably.
practical number at which you should be flying if you want to get the maximum range from the battery.
Battery. Now, I wonder for you, Cynthia, would there be now, like how we have speed limits on the road, would there be such limits for flying cars in the air? I mean,
I'm sure there would absolutely have to, determine what that looks like as well. And, who is controlling and helping people navigate what's around them in the air. And I think a lot of things come in to play there, right? It's how many vehicles are in the airspace at the same time, how fast is everybody traveling, and what are the rules based on the flight plan area, right? Because there's certain rules for speed and all kinds of things based on the different flight maps. So people will have to get comfortable understanding and how to navigate that, or potentially it's built into the programs in the car or in the vehicle already, to the point where what your maximum speed should be in that area.
so, I've just, you just said end of 2025 is when you plan to deliver the flying cars. No, that's, yeah. Oh, that's not what he. Okay, let's pretend everything did go right. I mean, I'm saying technically the cars would be there, but then would we have all these regulations, all these things in place now?
No, you won't. And that's why I think it's a global play at first, because the regulations are a little bit different outside of the US.
That's true.
I think it's going to take a number of years, quite frankly, before the FAA figures out everything. And if you want to Google I-28 or the FAA implementation plan, it is pretty well laid out. It's about 50 or 60 pages in length, and it talks about how they're interacting, not with a bunch of regulatory bodies, the Department of Transportation for one, local, city, municipalities, to figure out how to solve this issue. Also knowing that there's a significant air traffic system already in place today that is run by the FAA. However, they're not at this point in time contemplating what that looks like at a more local level. And that's really where they're asking, or it feels like they're asking the local governments to figure out what that's going to look like in their space.
So, Mario, when do you anticipate, when do you think we'll actually see this,
Well, there was a reason why I didn't put it in my book, because I can't think about that. But I think there are already limits to speed. For example, we know that supersonic the Concorde had that problem. They could not start flying supersonic when they were still over New York, right, or Paris. They had to fly out on the, and then there may be something else which I expect that. Depending if you're flying too low with high speed, you may be damaging stuff on the bottom, like throwing off tiles from houses. And you want to make sure. If you've seen Maverick, the Top Gun movie, I think there's one low flyover over the thing, and then even the roof lifts of that little cabin that they had there. So you don't want to have that, right? But and that's, I guess there will be layers on those things on the regulation.
So I'm assuming I'm not going to put in my order for $300,000 yet.
You should support a founder here. Yeah,
You actually can, because the deposit is 150 for the regular line and 1,500 for the premium line.
150,000.
No, $150.
$150.
That's it? Oh, okay.
Sure.
Okay. Yeah. Okay.
Actually, I'm looking forward for a jetpack. So,
Fascinating discussion. Question: Jim, you differentiate your aircraft, or excuse me, your flying car from a eVTOL, and liken the eVTOLs to essentially electric helicopters with multiple rotors. You mentioned you can't change the laws of physics. I agree with that. You also mentioned speed controllers and 8 engines and all electric. So am I correct in assuming that the difference in your design is you're using a ducted fan system or a series of ducted fans versus external fans?
So that's a very good question. Probably more deeper, because aeronautics probably deeper probably than most people in the room. This is why you asked that question. So it's a very good question. So let me try to rephrase it kind of like for most people. So the issue is this: you have the very limited width and length, right? You have the size of the car. That's a huge problem, because like airplanes, they're pretty big. They have like outside propellers, they have like large wings. I mean, this is why most of all designs look about the same. In order to fly efficiently, again, sorry if I'm going to go too basic, you have the shape of the wing, airfoil. And because the air pressure under the wing comes like faster than over the wing, that it pushes you up. When you fly today in an airplane, this is why you stay up. It's because of the special shape of the wing, right? So you need good wings, right? And you have like a big wings, and you have this shape, and then you fly at the speed, and this is why your airplane stays up and doesn't go down. This is how it works. So we have several problems. We don't have wings. We have the shape of the car. Second problem we have is the car is probably one of the worst possible shapes for flying, because it's actually designed to push you down and not to push you up. So you have problems with laws of physics. Moreover, some, and you probably saw them, have like expendable wings, like the Refugia and so on. You have a car and the wings expand. Here's the problem here. When you do that, you add so much weight that you require an airport to take off. If you need from here to go to Palo Alto Airport, to fly to San Francisco Airport, and then to go somewhere, again, horses will be probably your best bet. It's going to be completely useless. So you have problem with the laws of physics. I can give you an answer, but usually, okay, I'll give you an answer here. So you have the shape of the car. It's very hard to do without actually showing how it works. Again, you guys more than welcome to go online and Google "Ala flying car." You see how we turn into the airplane mode. So we need wings which weigh 0 pounds. And we have the horrible shape of the car. So first of all, by the way, we have the propellers right here, like right. The top of the car is open. It actually allows the airflow. It's in a checkered pattern. Again, it's very hard to explain without the pictures. But basically, this is the shape of the car, but it allows the airflow through, right? So you have the shape of the car. So one of my co-founders came up with something which is so simple, nobody thought about it for 100 years. You know, Henry Ford tried to do that. You know, many people tried to do the flying car. And for the same reasons, they could not, right? Laws of physics, you cannot break laws of physics. So you take the car, and where are you going to have the wings? You have a bad car, you have this. And he did something so simple that nobody thought of. He took the car and turned it 90 degrees. So now you have two wings. Now you have a biplane. Your whole side of the car, one side becomes the bottom wing, the other side becomes the top wing. Here you have the airflow coming through, and you have a DEP, distributed electric propulsion inside. Moreover, you have elevons for the better control because it's a tail, right? So you actually have pretty good amount of the area surface. Moreover, it's a circular wing also, which is also you can be to your advantage. So you have a pretty efficient way of flying forward. That's something so simple which people haven't done for 30 years. And that's exactly why they didn't, because the laws of physics stop you from that.
All right, I think that wraps it up for this discussion. Thank you all for joining. Any other questions, comments, panelists or hosts?
No, just wanted to thank our panel for a wonderful discussion. Can we get a round of applause? Thank you, Chris. Thank you to MoFo again, and thank you all for attending today, and have a good night. Thank you.